Ouch! That sudden sting you feel when you get a tiny cut on your finger can be surprisingly painful. It might seem like a minor inconvenience, but there's a lot more happening beneath the surface than you might think. You just got a tiny cut on your finger. It's small, almost insignificant, and you might be tempted to just ignore it. But hold on. That small cut is more than just a break in your skin. It seems like no big deal, right? Think again. That tiny cut is an open invitation for microscopic invaders. These invaders are always on the lookout for any opportunity to breach your body's defenses. Microscopic invaders see an open door and they're rushing in. These tiny organisms, invisible to the naked eye, are now making their way into your body through that small cut. Millions of bacteria, like tiny alien spaceships, are trying to make your finger their new home. They come in droves, each one with the potential to cause infection and disrupt your body's normal functions. It might look like a scene from a sci-fi movie, but this is happening inside your body right now. These microscopic invaders are real and they're on a mission to colonize your body. Luckily, your body has an amazing defense system, the immune system. This complex network of cells, tissues, and organs works tirelessly to protect you from these invaders. This system is made up of different types of cells that work together to fight off infections. Each cell has a specific role, and together they form a formidable defense against any threat. Think of it as an army with specialized soldiers, each with a unique role to play. Some cells are like scouts, identifying the invaders, while others are like warriors, attacking and destroying the harmful bacteria. Let's meet some of these incredible defenders. From the vigilant scouts to the fierce warriors, each one plays a crucial part in keeping you healthy and safe. So, the next time you get a tiny cut, remember the epic battle happening just beneath your skin. First on the scene are the macrophages. These guys are like the garbage collectors of your body, but with a taste for bacteria. Macrophages are large, amoeba-like cells that roam around your tissues looking for anything suspicious. When they find bacteria, they gobble them up in a process called phagocytosis. Imagine a big hungry blob engulfing a bunch of little dots. That's what's happening. But macrophages don't just eat the invaders, they also send out chemical signals to alert other immune cells that there's trouble brewing. Think of it as a 911 call for the immune system. Responding to the macrophages' call are the neutrophils. These guys are the frontline soldiers of your immune system. They're quick to arrive at the site of infection and are packed with deadly chemicals that can destroy bacteria. Neutrophils are like the kamikaze pilots of the immune system. They're not afraid to sacrifice themselves to take down the enemy. In the process of fighting the bacteria, neutrophils also release chemicals that cause inflammation. This causes the area around the cut to become red, swollen, and painful. Inflammation might seem unpleasant, but it's actually a crucial part of the immune response. The swelling helps to contain the infection, preventing it from spreading to other parts of the body. The redness and heat are caused by increased blood flow to the area, which brings in more immune cells and nutrients to help with the fight. Think of inflammation as your body calling in the fire department. It might be messy, but it's the best way to put out the fire and prevent further damage. Section 5. Dendritic cells, the intelligence agents. While the macrophages and neutrophils are busy fighting off the bacteria, another type of immune cell is gathering information about the invaders, the dendritic cells. These cells are like the intelligence agents of the immune system. They collect samples of the bacteria, called antigens, and carry them to the lymph nodes. Lymph nodes are small bean-shaped organs that are part of the lymphatic system, a network of vessels that helps to filter waste and transport immune cells throughout the body. Inside the lymph nodes, the dendritic cells present the antigens to another type of immune cell, the T cells. Section 6. T cells, calling in the reinforcements. T cells are like the generals of the immune system. They play a crucial role in defending our bodies against pathogens and ensuring that our immune response is both effective and efficient. They're in charge of coordinating the immune response and making sure the right troops are sent to the battlefield. Just like a well-organized military operation, the immune system relies on precise communication and strategy. There are many different types of T cells, each with its own specialized function. Some are designed to directly attack infected cells, while others support and regulate the activities of other immune cells. One important type is the helper T cell. These cells are pivotal in orchestrating the immune response, acting as the key communicators that alert and activate other immune cells. When a helper T cell encounters an antigen that it recognizes, it becomes activated. This recognition is akin to a guard spotting an intruder. The response must be swift and precise. This activation causes the helper T cell to start dividing rapidly, creating an army of clones that are all programmed to fight that specific type of bacteria. This rapid multiplication ensures that the body can mount a strong and targeted defense. Some of these clones stay in the lymph nodes to help activate other immune cells, acting as a reserve force ready to be deployed when needed, while others travel to the site of infection to join the fight. These traveling T cells are like emergency responders, rushing to the scene to provide immediate assistance and neutralize the threat. The coordination and specialization of T cells are vital for maintaining the body's health. Without them, our immune system would be like an army without leadership, directionless and ineffective. Research continues to uncover the complexities of T cells and their roles in immunity. Understanding these cells better can lead to advancements in treatments for various diseases, including autoimmune disorders and cancers. By harnessing the power of T cells, we can develop more targeted therapies that enhance the body's natural defenses, offering hope for more effective and personalized medical treatments in the future. Section 7. B cells, antibody factories. Another important type of immune cell is the B cell. B cells are like the antibody factories of the immune system. They produce Y-shaped proteins called antibodies, which are specifically designed to bind to and neutralize the invading bacteria. Antibodies work in a few different ways. They can bind to the bacteria and prevent them from infecting cells. They can also mark the bacteria for destruction by other immune cells, like macrophages and neutrophils. The production of antibodies is a key part of the adaptive immune response, which is the body's specific defense against particular pathogens, like the bacteria that invaded your finger. Section 8. Memory cells. Remembering the enemy. After the infection is cleared, your body doesn't just forget about it. Instead, it takes a proactive approach to ensure that you are better prepared for future encounters with the same pathogen. It creates memory cells, which are long-lived cells that remember the specific bacteria or virus that caused the infection. These memory cells are like your body's own personal health journal, keeping a detailed record of past invaders. If you ever encounter that same type of bacteria or virus again, your immune system will be ready to mount a faster and more effective response, preventing you from getting sick. This rapid response is due to the memory cells recognizing the pathogen and signaling the immune system to act quickly. So the next time you get a cut, remember the amazing battle that's taking place inside your body to protect you from those tiny invaders. Your immune system is constantly working behind the scenes, using its memory cells to keep you safe and healthy. It's a remarkable system that ensures you are always ready to face the challenges posed by harmful pathogens.